So we have a recording running now, and this is the week 7 evening session. So it's just after 8 o'clock. We took a little bit time to get started, and we'll cover really quickly something about previous week, and then we'll move on to talk about what's up with this week's material. As I was saying before, please do feel free to ask at any stage if there's something that you're kind of, even about previous material, that you're just wanting to hear a refresher. It doesn't even have to be that you wouldn't have gotten it. So one question that came up, and sorry, I'm trying to navigate my windows here, was to have an idea of the blood flow from the heart and back to the heart. So what we're really wanting to do here is have a somewhat healthy appreciation of the vasculature of the heart or vasculature of the body. So I'm just going to start by putting here, you should be able to see my screen, I hope. Our heart as we've seen it before. And we had our right atria, right ventricle, left atria, and left ventricle. And we're not going to be paying too much attention to the blood flow to the pulmonary circuit. That was to the lungs. So we'll just skip that part and we'll focus to the rest of the vasculature on this review. And what I'm going to do, I'm going to use the colors to, if I manage to pull them up, colors to simplify what kind of blood do we have now? Is it high in oxygen or is it low in oxygen? So the blood that's leaving the heart to the systemic circulation leaves our left ventricle through the aorta. So we're going up here, and aorta is one of our very first vessels that we're going to have a look of. And we remember that the blood vessels that we end up finding here are I'm trying to write, but it's not. Arteries. This must be like the weirdest writing ever. Artery, arteriole, and then we have our capillaries. And just to kind of revise really quickly, we had different kinds of arteries. And you remember that aorta is the first vessel that comes out. So aorta is now dealing with this high pressure and pulsatile flow of the blood that's coming out of the heart. So arteries in general have to be adapted to be able to handle that fluctuation in the flow and high pressure that we're putting to the blood that's pushing against the walls of the heart, walls of the blood vessels. So we have two different kinds of arteries that we want to know. We've got our elastic, and an aorta would be an example of elastic artery. Elastic arteries kind of just try to deal with this high fluctuation of pressure. So they're the very first arteries that leave the heart. And then we've got muscular arteries. Muscular arteries come up here further down the road, and they are more involved with distributing the blood to various different parts than just dealing with this pressure fluctuation. But what we notice is that arteries are much more elastic in their structure. They're much more adaptable in terms of controlling and making sure that the pressure is high on the artery side of the circulation. The other thing that the muscular arteries now start doing when we go further down on this loop, they start slowly decreasing that fluctuation, and slowly we are getting ready to bring down the pressure before we reach the capillaries. So by the time we got to the arterioles, there was an adaptation that's going to be important. And hi, Janessa, just to give you a heads up, we're revising something from the previous chapter, so don't feel that you're at the wrong week or anything. So we have at the end of the arterioles are pre-capillary sphincters. So I'm just going to abbreviate it as pre-capillary sphincters. And I probably misspelled that, but that's how we're going to go with that. So you remember that the role of the pre-capillary sphincters was to make sure that we have more capillaries than we have blood. So these are the ones that choose that to which capillaries and which capillary beds do we direct the blood to. So capillaries were these very, very narrow blood vessels that were easy for the substances to cross over those walls, both out of the blood, but also back into the blood. So these are the main side of exchanging materials. So what I'm going to try to do here, just for the interest of time and avoiding my artistic abilities, these are the pre-capillary sphincters that we're seeing. They're right before the capillaries where the arterioles end. So we are seeing them here. And after the blood has passed through the capillaries, which was the main site where everything gets exchanged, we now have low blood pressure. This is because we needed to decrease the blood pressure before we got to the capillaries, because if there was a high blood pressure and we have thin walls of capillaries, we would just end up bursting those capillaries and blood would flow out of our cardiovascular system. That would not be great. So now we have low blood pressure, and we're going to face some challenges because of that low blood pressure in how are we going to get the blood back to the heart, to our right atria, because now we might be even working against the gravity and we still have to get that blood brought up. So what we have our venules, which were basically just small versions of veins, and then we have our veins. So we are moving from the smallest blood vessels with the smallest diameter, which was just enough for a red blood cell to squeeze through, to now a little bit wider and wider and wider. So as we are moving back towards the heart. Now you notice that the blood is going to be deoxygenated. So the oxygen has been taken away. And really, the big thing to remember with the veins was that we had valves. So those were similar that we saw in the heart that made sure that blood can only go one direction and one direction only. So we're preventing the backflow of the blood to where it shouldn't be going. And when valves failed, sometimes we could end up seeing a clinical condition of a spider veins or whatever term you prefer here in America for this. So we end up seeing problems with the blood pooling on top of the functional valve underneath the valve that has failed. I'm just trying to think of the name in English. Oh, it's really bothering me. So we're seeing
varicose
veins. That's the word that I was thinking. Thank you. I appreciate it. What happens when you speak two languages, you have the wrong language on your mind at all the time. So that's really the big order of the blood vessels. Does that make more sense? I know that in capillaries, we went through two different kinds of capillaries, and I can add those to this diagram if that's something that you think that would help. So what we had our, I'm just looking that I'm using the same terms that I've used before with you guys, so I'm not getting anyone too thrown off with by starting to go through other things. So in capillaries, okay, let's do it quickly and then we'll wrap up. So in capillaries, we had continuous capillaries. So you remember on these ones, the wall, there were no gaps at all. All of these simple squamous cells were laid out in a way that there were no gaps in between them. The next type of capillaries that we had fenestrated capillaries. And fenestrated capillaries looked a little bit like a Swiss cheese, so there were small holes here and there on the capillary wall. So enough for stuff to go in and out, but not so much that everything just sneaks out of there. So Swiss cheese was probably the best comparison of the fenestrated capillaries. And then the capillary type that had the most openings was called our sinusoidal capillaries. And on these ones, we really saw that almost like parts of it were missing. And this facilitates a lot of bigger material, bigger molecules to go through and be exchanged, both out of the cardiovascular system, but also back into the cardiovascular system. So I hope that makes a little bit more sense. If I were to be asked, what do you need to remember about the vasculature? Probably that would be a pretty good summary. In addition to that, we of course talked a little bit about blood pressure, and blood pressure was the force that we put against the vessel wall, and that varies a little bit depending on where in the world we are and where in the what time we're looking at. These keep changing a little bit, but something roughly 120 over 80 or 120 over 90. And those two values were our systolic and diastolic blood pressure. So I hope that you're comfortable with those. Systolic was when the heart ventricles are contracted, and diastolic when the ventricles are relaxed. And after that, we talked about the hyper and hypo. Hypertension and hypotension. So hypertension was when we had too high of a blood pressure, and issues with that came that you have a greater risk of, for example, having stroke or having leakage, having breaking those blood vessel walls, whereas on hypotension, you just had a low blood pressure, and that had less of a worry or less of a trouble than what we see with hyper. But again, we kind of want to make sure that we have enough blood pressure that we're able to still have the blood to do its job. But that's all I can think of the vasculature that's really like the key points. I hope that helped. I'm looking at this drawing and it's really, really messy. I'm sorry. If you look at the video, there's a prettier picture of that, but those are the key words at least. I think that if that's okay, give me a shout out if it's not. I think that if that's okay, we're just going to move on because we've got a few different things today that I want to go through, and I really want to make sure. Okay, I'm glad to hear that it's all good. I want to make sure that you all get a chance to see the most important things. The review of this week's lecture material, that's going to be available as a video, as is this one as well, but I do want to make sure that we talk a little bit about next week as well. So I want to talk quickly about this week's assignments. There's no curveballs in the assignments except the fact that a lab is done yet again on a new way. But this way, how the lab is done is really easy. This is like old school. You have a document that you can print or you can open on your screen, then you fill in answers to that, and then you just upload it to the canvas. And you find those answers while you work through a website. So it's really as simple, as little technology as we can make sure. So it should be good. Then I want to talk, of course, review the immune system and lymphatic system really quickly. I think we're going to mix up the order a little bit. I'll save that as the last part. And I do want to talk about the exam too and lab practical too, because they're next week. I can't believe that we're already that close to that. I see the faces on the screens. That's how I felt, that what is happening? How are things going this fast? I know that few students are still catching up on the material. If you're catching up on the material, I am totally fine to open that you can take the exam and lab practical next week or the week after. So there's no reason to take the exam without having gotten through this week's material. So deep breaths, we can make this work. But for the exam and lab practical, I want to make sure that we have review sessions. And sorry, I'm gonna jump here, and I'm gonna add that we're gonna have review sessions both on Mondays and on Wednesdays. I should be back on the PowerPoint. If you're not seeing it, then you wave or shout out something. But I want to offer a review session right at the beginning of the week, and then I want to keep our normal review sessions. So we're going to have those on Mondays and Wednesdays. And again, there's going to be a study guide. And on those sessions, we're going to go through that study guide. So that's a good chance for you to get the material for that. Format of both exam and lab practical are as before, so you don't need to do them as proctored and all that. We'll talk about that in a second. what I really wanted to say, and this was when in the morning I was feeling very energetic, that I can't believe that we're already on week 7, because I was doing a little bit of math, and we've got a course that's 16 weeks plus final weeks. That puts us nearly to 44% of the weeks that we have completed. So by the end of next week, when you have taken your second exam and second lab practical, you are almost at the halfway point of this course, or you are at the halfway point of this course in terms of the length of the course, in terms of point accumulation. You are not quite at the halfway point yet, because you remember we have final that then gives a lot of points. And finals is going to be much, much, much more easier than what you're expecting. Not easier in the sense that you don't have to put in any effort, but I'm not going to be looking for you to memorize stuff. I'm looking for you to show that you've learned stuff. So we'll talk about the final in a second. But before that, I did want to quickly discuss about the assignments for this week. So the 3 first parts, there's 4 parts of assignments for this week. 3 of them are familiar things for us. We have seen before the Learn Smart, which was basically you answered the questions. I think there was some how confident you are about your answer. There's a link to the textbook electronically where you can look at a section if you're not sure about the question. And as long as you work through them, of all of the questions, you get 100% for that. It's just going to keep asking those questions again if you keep missing them. Then you have the quiz, and I do realize I looked through it. You guys were absolutely right. The hard quiz, that was a killer one. 65 questions or something like that. I went to do it myself, and I was like, it was a lot. I'm going to phrase this as PC as I can. Because we've got different sections that are doing this same class, we try to keep that the homework and exams would be fairly similar from one section to another. So that quiz in particular was set up by someone else. I think it was a good quiz, but it was a lot to do. So I'll leave it to that. Just so you know that everyone else is having to do that long quiz as well. And then we have the practice anatomy, which is what you've seen before, that there's those videos from my colleague that talks through the structures, and then you kind of match things. All of these are due at the end of this week. But again, like I said, I totally get it that people have at this time of the semester, things get really busy with other courses as well. If you need an additional week, you just let me know. If you need an additional 2 weeks, you let me know. How I ask you to let me know is that you send me a message here in Canvas. The reason why I don't answer always immediately to that message is that until I have actually done those changes, I don't send you a message, because if I send you a message, I will do it. It's guaranteed that I'll forget to do it. So I respond to you that it's been done, and you can access those with the additional time that has been allocated or whatever. So I'd rather that you have time to do the homework properly than that you just rush through it so that you get it done. But those are all things that we've seen before, and you see the point accumulation as well. I think good way to think of the points is that for each practical is worth of 50 points. So it's like doing 5 quizzes. So if you miss all of the quizzes, you really have to ace all of the exams. So kind of think of it this way, that as you keep doing these homework assignments, they are points towards your final grade. Grab these points, and that's why I want to give as many chances for you to get them done at whatever time you wish. So these are all things that we are familiar with. The new thing is going to be the immunology virtual lab. So this is a lab again. And we're not actually looking at the lymphatic system on the lab. We're looking at the immunology, because that's kind of a little bit of a harder concept, and that's very functional rather than anatomical. So it's very much of physiology. So I think a lab is very good for that. And this lab is not done like any of the labs that we've seen so far. It's easier in a way of technical application. So You will not access this lab from the Connect, where you normally find all of your homework. Instead, you need to access this lab through our Canvas course. So make sure you come to the Canvas when you are taking this lab. And this lab has no limit how many times you can try it or whatever. So you can have a look of it, you can leave, you can come back. What you will basically do when you first click on this lab, and the name of the lab software or lab offering that we're going to be using is Biointeractive Lab. It's a website where you go. And before you start that, what you do as the very first thing in the Canvas, you either download or you print a worksheet where you get basically the questions that I'm looking for answers. Some students prefer to print it if they prefer to do the old style pen and paper. Some students prefer to do everything electronically, so they just download that. It's not Labster, thank God. Labster is hard one to integrate on most of the learning management systems. So this is something much more simpler. So basically, you just make sure that you get this question sheet. And the question sheet is really going to look like this. You see that there's not a huge amount of questions on each page, but I think that there's going to be 6 pages in total. And I don't think that the last page was even full of text. So these are questions that you will find answers from the lab as you work through it. And I'm not looking for a perfect answer as in a textbook or as in a dictionary of definitions of things. What I'm looking for you is that you simply understand the concept. So any way you can explain it. Some students prefer to draw me diagrams. Some students prefer to give just bullet point answers. However you prefer, but just show me that you know what you're talking about. And once you have made a copy of this question sheet or downloaded it for yourself, you will actually go to a link that's on the Canvas site. And that link is to a website on Biointeractive. It basically looks like this. It's a website where you start the activity, you work through the activity, and on those websites you get told everything that you need to know for this. There is going to be also a chance that you can just leave it and come back. You can try it as many times. All you need to do for points for this lab is to complete the lab sheet that you just got and then upload it to the Canvas. So if you do it on a computer, you can just upload the PDF. If you do it manually, you can scan it or you can take a picture of it, however you wish, but you just upload it to the Canvas. The reason why I'm not doing paper things that you give to me, because we're closed. I can't really go and collect them and I don't want you to mail anything. It's just easiest if you just upload it on the Canvas and then I grade them and then you get your lab points. So it's really, really straightforward, much more straightforward than any of the other labs so far in terms of the technology. So we should be good on that. Any questions about the lab? It makes sense while you start working through it, but any questions at this point? We feel good. We're going to go through the key points of the chapter in a second, but I also want to mention a couple of words about the exam and lab practical. So these are next week, and those are the only pieces of assignment that you have for the next week. So there's no new chapters, there's nothing new to cover. We will cover in the exam the chapters about heart, blood vessels, and then what we're going to discuss this week, the lymphatic system and the immune system. I want to keep the amount of material in an exam as very manageable so that there's not too many chapters, and especially not too many chapters that are totally different or totally unrelated. So I want to keep them a small amount of things to study. So that's why you have that many exams. This is in a format that there's going to be the study guide, and I don't give answer document for the study guide. On that study guide, again, there's going to be gaps, and the only place or only time where I will go through those answers to those gaps is going to be in the review sessions. However, those review sessions are available as recordings for you to access. But I got a lot of questions last time that could I send the document with the answers to the study guide. The reason why I don't do it is that every single question in an exam is from that study guide. That would be almost like me giving you the answer sheet that then you just have to, your job is anymore going to be just finding those answers. That would be probably not serving the purpose that we want to do. So you can do your study guide, fill it, and there's no proctoring. So it's totally open book test. So you can use your study guide. You don't need to have responders open. If you do, very nice. I appreciate that. That's a good thing to do. But you can have all of your notes, all of your textbooks. You can even Google answers when you're taking the exam. There's nothing in terms of testing setting that would be different from the last time. I think it's going to be 50 questions. Last time we had 50 questions, and I thought that was a good number, but I am reserving a chance that I might change that number if I get really carried away when I'm writing the exam. I've written pretty much, let's say, 75% of it. But just because I want to make sure that I ask questions about all the chapters equally, I might add a few more questions than 50. So this is not a promise that it's 50 questions. The questions are like you saw last time, mainly multiple choice. It might be true, false statements. It might be matching. It might be ordering things. But really all things where you pick answers from what I'm giving. The reason why they are done that way is that they're going to be automatically graded, and there's less of an ambiguity of the spelling or anything like that. If I'm asking you to fill in a term, I'm usually offering a list of terms, and then you pick the right term from that list on the question. Questions on the exam are only about the lecture videos, so only the material we've covered on those videos that I have prepared. So again, nothing outside those. There might be things that I've said that, okay, make sure to have a look of this independently, then that's fair game for the exam. But I would have highlighted it to you, that, oh, this is an important one and you need to have a look of. I can't really think of anything else other than the review sessions. So at the beginning of the week, on Monday, we'll do both the morning and evening review session, and then I'll do those again on Wednesday. The material on all of the review sessions is going to be the same. So you only have to attend to one. You're welcome to attend to more than those if you wish. Any questions about the exam? Looks good. Please don't feel overwhelmed. It's really the same as last time, just the questions change. But make sure if you have the chance to not have to take exam as proctored, make sure that you use the tools that you have available. Of course, you can always make your life and make it difficult and show that I can remember all of this. But what I'm looking is not that you have to remember everything. I'm looking that you have to understand. And you're not going to get an A for this exam if you have never looked at any of the notes, if you have never opened a single one lecture video. I'm not asking you to memorize things, but I'm at least asking you to know where to find the answer from your notes. I'm going to jump to the practical just in the interest of time, unless there's questions, but you can shout out at any time. The practical, again, we're going to have the same format as the last time. So it's going to be fill in the blanks. And I know that last time I took a little longer on making sure that I reviewed the spelling and all of those differences multiple times. I'm trying to be a little quicker this time around. But what I want you to do is not worry about spelling, not worry about, oh, do I have perfect punctuation? Do I use the hyphens correctly? What I want you to do is just have the feeling of what the word would be. So I'll manually correct. Your initial score, because of the automated grading, might look worse than your final score ends up being. But make sure that you answer to every question something. Even if you don't know the answer to what I'm asking, if it's a name of a structure, then try to think, could I know what the structure does? Or could I know a structure that's close to it? Could I know something that you can tell to me? Because if you tell me something, I can give some points. I might not be able to give you full points for that question, but give me something to work with, and I will try to give you some points for that as well. It is open book, so I really do want to highlight, you don't have to do it as a proctored test. You don't have to have the responders open. Of course, you're welcome to have the responders open if you feel that that helps. You can do it from anywhere. You can have your notes open. You can have your, if you've downloaded pictures for yourself or taken screenshots while you've been studying, all that is available. It's not going to be dragging things to match with the terms with the structures. It's going to be filling blanks. And there's going to be anatomical structures, so organs, for example. There's also going to be histology, but not quite as much as last time, because now we actually have things to ask questions of, such as, for example, the major blood vessels of the heart. Are you able to pick aorta? Are you able to pick where the right atria would be? Are you able to tell where the anterior interventricular sulcus would be? So stuff like that. There is going to be some histology, but not quite as much. And there's going to be vessels as well, both from the blood vessels and also from the lymphatic vessels. So you remember when we talked last week about blood vessels, I uploaded on the Canvas a bunch of these diagrams where it showed the blood vessels in various different parts of the body, or just the general blood vessels in how we have them in the body. I would really have those available, because it's very possible that you're being asked of some of the major blood vessels that you can identify. And I know that we didn't go through those in the lecture videos to as great of a detail, but they are something that might come up in the practice. That's not all that practical is going to be, but there's going to be some questions from that. And you'll notice that last time we had 25 questions, now we have 50. So it's double the number of questions, but you also have double the amount of time. That means that you have basically 1 minute per question. 1 minute is a lot of time, so don't let that freak you out, because you either know the structure or then you don't. 1 minute is normally the amount of time that we give in any university if you're working, for example, with catheters, if you're working with anatomical models. And if we were to do this face-to-face, you would have stuff on the table and they would be stations, and you would move from one station to another station once a minute, so that it would be like a circle that we walk around and we fill in the names of those structures. Usually your initial gut feeling is the right answer, so don't get too bugged out of kind of like, oh, I'm gonna think of this one question now for 15 minutes and rush through with everything else. Remember, you have your notes, and in this case you can go back and forth as well, but really I would try to answer something to all of those. And again, it's gonna be the key terms. I think I'm gonna offer some sort of a list of key terms from each of the chapters that we've covered in terms of the anatomy of those chapters. So there's going to be some sort of a study list of key terms, but it's not totally inclusive, that doesn't only include the ones that we're going to ask, and there might be some that I forget to include to that, but I'm going to try to do the best I can. So that's basically the practical and the exam. In the exam, there's going to be an extra credit question again. Extra credit, I hope that everyone knows you can earn more than 100% of the score in my exams. So that's a chance to reclaim some points. And there are going to be things that I've highlighted to you earlier in the lecture videos, that this would make a good exam question or this would make a good essay question. And I'm going to highlight those also once we do the review sessions. Any questions about the exams, practicals? No? And like I said, if you're still catching up with the material, I want you to have had a chance to go through the material first before you take the exam. So if you need an additional week, I'm okay with that. But I'm just going to have to keep going like 1 week at a time. So students who are ready to move onwards have also new material available. Same goes to what I've said on the before about retaking assignments, or if you have missed assignments, I'm totally happy to help you to take those. Make sure you message me. The Canvas is the best place to message me with details of what those assignments are. It helps me if you give the name of the chapter, or you give me the name of the system, or you give me name of the week, what week we are doing. When I get that, oh, can I have this week's assignments or last week's or the week before, then I really have to do math of working out when you send me that message and what week you are talking about. And I might open you something totally wrong. So try to be very specific, and I will be more than happy to open those. In terms of you have the tutoring available, and I'm happy to offer help as well. In terms of the final exam, I want to mention here for you guys as well, because I mentioned it to others, that final exam is going to be more of a project that you do. I don't want you to spend time memorizing stuff. It's not going to be going back that you have to now study everything you've studied in the previous exams. It's not also going to be just the material from that week. How it's going to be, and I'm still writing it, so it might change a little bit. It's going to be that you have many different ways that you can show me that you've learned something on this course. So we have course competencies that you're supposed to get from this course. That's the list, and it should be on your syllabus, and I will post it for the finals as well. But there's different things that are the key points that you need to learn from this course, and you're going to pick one or a few of those, and you can either write an essay, or you can do a presentation, or you can do a nice poster or a diagram or animation or a story or a play if you wish. You just somehow demonstrate that you've learned some of those learning points, and how many, or some of those competencies, and how many of those it's going to be, and so on. I'm going to still have to work on that. But it's not going to be memorizing stuff and then having to repeat it in an exam setting. So it's much more creative. And the goal of that is to make sure that you have a chance to get a lot of those points that you need for your final grade. One last thing with the finals week. On the finals week or before that, what I'm trying to do, and the reason why we're doing the finals this way, is I'm trying to make sure I have time to sit down with each one of you one-on-one through virtual setting. It's not going to be a long meeting, but for maybe 5 minutes, 10 minutes to discuss where you are with your grade, where you want to be with your grade, and are those two going to meet? And if you feel that you wanted a higher grade and it looks that you're not quite getting there, I normally am happy to give you extra work worth of 1 grade letter that you can bring up your grade. But if you're now getting a D, and it's the last week of the semester, you're probably not going to be able to make it up to an A. But if you're getting a B and you really need that A, there's probably going to be extra assignments that I'm able to give. So that's all from these practical things, only thing that I can think of that's left for today is to go through the key points from this chapter. But before we jump into that, do you have any questions about anything that we have covered so far? I know that was a lot. I'm kind of also getting tired of hearing my own voice. I don't know how you guys are surviving because I'm done with myself. So let me just jump to a different PowerPoint. And if you, I don't know, because it didn't look like it worked, this morning's recording, but if it does work, and if you look at those, you might see that for the morning session, I hadn't totally branded the slides to this school's or this college's branding. So it kind of revealed where I still work, I hope. But these are now more keeping in line with our visual appearance. So what I want to do, we're quickly going to go through both lymphatic and immune system. We're going to spend a little bit more time on the lymphatic system, and I'm just going to highlight the key points. There's, again, lecture videos, and my computer is counting on the background, uploading those to the YouTube. So they're going to be there tomorrow morning at the latest. But what I want us to do is that we're going to be focusing on the lymphatic system. Since lymphatic system is something where we actually have both anatomy and physiology. Immune system is, if you hated the endocrine system, immune system is going to be similar to that. It's simply a functional system. It doesn't really have anatomy. So it's much more abstract to think about. So we're going to spend a little bit of time on that, but not quite as much. Do I expect you to be experts of lymphatic and immune system by the end of this week? Absolutely not. I just want you to have a basic appreciation of those. And I want you, especially since immune system, now with COVID-19, everyone seems to be an expert of immune system. I want you to be able to have like an intelligent discussion with someone. I don't expect you to solve the COVID issue, but I expect you to have a little bit smarter things to say than what a lot of people are saying now, because it seems that we've got experts of all kinds. So I'm just quickly going to show that really, like I said, I think at the end of last week, was that our lymphatic system is almost complementary to the cardiovascular system, and especially the vasculature on that. So if you think that we have the vasculature here, it was a closed loop where the blood flowed and blood wasn't really supposed to leave that. But some of it leaks out regardless of the cardiovascular system of our blood vessels. So lymphatic system is almost like a drainage that catches anything that leaks out from your vascular system. So they're very much connected together. But at the same time, lymphatic system has an important role, or multiple important roles. And the main important role that lymphatic system has is that it gives the place for the immune system to work in. So immune system basically lives inside the lymphatic system because it doesn't really have anatomical structures. So it's a little bit of a free rider in that sense. So that's why we're covering both of these chapters as one. The reason why you might want to learn about this, if you think of the fields where you might be heading, is of course when doctor checks your lymph nodes. What we are doing there essentially is that we're looking if you have an infection somewhere in your body. This is a very simple test, very simple way to get understanding of your whole body's well-being, because it doesn't matter where in your body you might have that infection. If you have infection that's significant enough, we will see that lymph nodes have gotten swollen, they're sensitive, and there's many other places than just here in the neck where we find lymph nodes. So that's why we need to know about what they are normally before you can then notice in a patient when they're abnormal. And I just don't want anyone to miss their class if they need to go. So I'm just putting a shout out. It's 9 o'clock. But like I said, I promise that I will have all this material recorded as well. In terms of the lymphatic system, I really want us to start by talking, what does lymphatic system do? But before we can really understand what lymphatic system does, we need to take one step further back and go back to our chapter on the, okay, good. I'm just making sure that I give shout out regularly enough, and I try to be much quicker and finished before that. But basically what we need to do, we need to go back to talk about the capillaries of the vascular system before we can understand the lymphatic system. So what we noticed was that we had two different forces working on those capillaries, hydrostatic and osmotic pressure. And you remember that it was the hydrostatic pressure that was pushing stuff out of the capillaries, and it was the osmotic pressure that was pushing stuff back into the capillaries. Well, if we actually look at this in numbers, what we end up finding that out of the blood that travels through the capillaries, in the process that's known as capillary filtration, so that's the exchange of the materials through the walls of the capillaries, and outside the blood vessels, we've got plasma. Out of that, in a single day, 20 liters of fluid leaves the blood vessels to a space outside the capillaries. It doesn't go inside the other cells, it just goes to the interstitial space. 20 liters is quite a lot. I can't do in my head the conversion, how much that is in an imperial scale, but that's a lot in a single day. That's because of the hydrostatic pressure. However, osmotic pressure recovers 17 liters of that back to the blood and back to the cardiovascular system. So that leaves us with 3 liters that's left outside the capillaries that we're losing from the blood or from the cardiovascular system. And we need to do something about that 3 liters, because if we get 3 liters every single day building up in our body, we're soon going to look like the Michelin Man or whatever. We just need to do something about that 3 liters. So what are we going to do? What we do is that we have lymphatic system that now catches this remaining 3 liters and collects all that extra fluid that leaked out and transports it back to the cardiovascular system. Right before the heart, we dump all that liquid back to your cardiovascular system. So that's the function of the lymphatic system. And there were a couple of terms that I do want us to take a little bit of time that we realize where these terms are used and at what time. So within the cardiovascular system, you have blood, and blood contained plasma. Well, now some of that content of the blood leaks out of the capillaries to this space that we saw here, this interstitial space outside the capillaries, but also not inside the cells of the nearby tissues. This is interstitial space. And when that liquid leaves the blood, it's actually plasma that leaves from the blood here. All the big molecules, all the formed elements, they stay within the cardiovascular system, within the capillaries. But what leaves out is some of the plasma. Well, now this plasma is no longer called plasma since it's outside the cardiovascular system. Now it's called interstitial fluid. So blood turns into interstitial fluid or the part of the blood that leaves the capillaries becomes interstitial fluid when it leaves the cardiovascular system. Well, I said that the function of the lymphatic system was to catch that fluid. And what we have in the lymphatic system is lymph. We don't have interstitial fluid there. Well, when does it become lymph? That's one of my favorite questions to ask from students in an exam. Well, this fluid becomes lymph when it enters the lymphatic vessels. So once it's in the lymphatic system, we talk no longer about interstitial fluid, but we talk about lymph. But if you look at the composition of the plasma in the blood, composition of interstitial fluid, and composition of lymph, it's all the same. There's only very little changes. So you can think of it being all the same stuff, but the name changes depending on where it is in the body. So make sure you know that lymph is when this interstitial fluid now enters to the lymphatic system. Then we start talking about lymph, and we no longer talk about interstitial fluid. What I wanted to say here was just like I introduced already earlier on, that the lymphatic and immune system are going to be linked. So lymphatic system is the anatomy. There's a little bit of physiology as well, but immune system is simply totally physiology. So it needs to have a place where it functions. And immune system functions inside the lymphatic system. So these two are very, very closely linked. So what we're going to go through on this chapter about lymphatic system is look at the lymphatic vessels, then we're going to talk about the lymph a little bit, and we're going to finish off by looking a little bit of lymph nodes. So those are the three important topics that we'll talk. So if you think what we just drew at the beginning of this class, and I'm kind of really grateful, I'll give you your $20 later on for asking that question. No, but I'm really grateful that you asked of that this is the systemic loop of our cardiovascular system. So we have our heart, and then we have our arteries, our arterioles, and then our capillaries. And then we had our venules and veins, and the blood goes back to the heart. This is the systemic loop. And you notice that I've left out the pulmonary loop just for the simplicity, but you'll notice the cardiovascular system where the blood travels is one-way system, so blood can only go one way in it, and it's a closed loop. So blood is not really going and wandering off somewhere and coming back. We noticed a little bit of that happened at the capillaries, but that's very little. In some other animals, we don't, for example, have blood vessels at all. So blood just travels inside their body. Well, what we get lymphatic system, which was basically open from one end, where we had the capillaries. On this end, it catches any of that extra fluid in it, and it transports this lymph one way. So it's again one-way system, but this time it was open from this end, and it transports it all up here. Right before the heart, we dump the lymph back to the cardiovascular system, and then it goes back to that circulation. So that's how we get rid of that 3 liters a day. What you'll notice is that there's a lot of similarities between the lymphatic vessels and our veins. We end up finding same valves. We end up finding that their walls are very similar. Only big difference is that the walls of the lymphatic vessels are much more permeable. So it's easier for stuff to travel in there and be grabbed by them. So when we are going through the different kinds of vessels that we have in the lymphatic system, we have the same stuff that we had in the cardiovascular system. We have capillaries, and you notice that these capillaries are right where our capillaries of cardiovascular system are. And these capillaries are very, very permeable, so they're taking up anything that leaks out from there. Other thing that these capillaries are taking up is something that we haven't yet talked about. But when we talk about the digestive system, we notice that there's a lot of blood circulation on your abdominal area. And that's because we try to catch all the nutrients, all the energy from your food to the blood there. And then that blood travels to elsewhere in the body. Well, sometimes there's fat molecules that are way too big to be caught by the cardiovascular system at the capillaries to go into the blood. these big molecules are picked up by lymphatic vessels, and the big molecules travel within the lymphatic system close to the heart, where they then get dumped into the blood. So that's one function. The other function is that lymphatic system regulates this fluid balance, of course, that we don't end up with the 3 extra liters every single day. And the third function is that lymphatic system helps with our immune system. So that's our body protective functions against pathogens. What we notice about the capillaries, they're very, very permeable. They can take up bigger things than our blood vessels do. Well, we also have, sometimes that's beneficial, sometimes that's problem. Problem could be if we take up on our lymphatic system things that shouldn't get into your body. For example, some people don't like surgery for their cancer tumor, because if you cut into that tumor and the cancerous cells get into your lymphatic system, they can spread through that lymphatic system to all parts of the body. So we try to make sure that we don't let things get into the lymphatic system that shouldn't get in there. Same with pathogens. If one pathogen gets there, it can spread to all parts of your body really easily. But also in a positive way, that we're able to regulate the fluids from all over your body there. Well, what we see with the lymphatic vessels is that then they grow bigger and bigger and bigger, as we've seen elsewhere with the veins and arteries as well. So we have vessels, we have trunks, and then we have ducts. So they're bigger, bigger, bigger as we move on closer to the heart. And what I've got here is an example from inside your thoracic cavity. So now we've taken away, what you see here is our esophagus and our trachea. So for our windpipe and then the tube to the stomach, we've cut them off so we can see better to the back of your thorax, back of your chest cavity. We've also removed superior vena cava and inferior vena cava. You remember these were the vessels that brought the blood from the body to your heart. So we've taken those away as well. This is just to kind of give you anatomical landmarks. At the back, close to the back of your chest cavity, you can see a couple of important lymphatic system structures. First of all, you can see thoracic ducts running throughout the entire thoracic cavity at the back. And you'll notice that at the very inferior part, at the bottom of the thoracic duct, it expands. It grows into a bigger sac. Not quite as big as a golf ball, but it is significant when you look at it in a dead person, for example. This sac is known as cisternaculi. So that's a structure that you might want to know as well. I'm not guaranteeing that it's going to be in your lab practical because I don't really remember. But I'll remember them hopefully by the time we do a review session. So we go from vessels to trunks, and then we go to the ducts. Bigger blood, bigger lymphatic vessels. And there's few different trunks that we can find in the body that are important for us to know. Well, it's easy to identify those because their name tells where they're located. So we, for example, have a lumbar trunk. That's at the lower back. We also have our interstitial trunk. Well, that's where your intestines would be. I will have this diagram available for you to download on your Canvas course. So don't worry about writing them down. You can print that handout, and then while you're studying, you can highlight or whatever. You also have intercostal trunk. We just looked at the chest cavity, and you notice that there were ribs. Well, between the ribs, you have intercostal space. So these trunks of the lymphatic system run between the ribs. We also have our bronchiomediastinal trunk. That's where the bronchi and mediastinal area are in your chest cavity. We also have subclavian trunk that runs under, so subclavicle, runs under your collarbone. Jugular trunk, that's the one at the neck that that drains the lymphatics from there, lymph from there. Well, then we get to bigger structures of the lymphatic vessels. These are ducts. So we have right lymphatic duct on the right side of the body, and we have thoracic duct as well. We talked about the thoracic duct on this diagram that we had a look. So really, the key thing is to just be able to realize that these terms are related to the body parts where you find. So really, again, I was thinking, how do we relate this to something that you actually need to know? Well, if our lymphatic system doesn't work properly, we end up with edema. And because it's now lymph that's causing this edema, it's called lymphedema. Some of the causes why you might end up with lymphedema is if you have a tumor, for example, blocking one of the lymphatic vessels, or if we have to remove lymphatic vessels because of some conditions that you might have. Usually, there's alternative ways for the lymphatic vessels to find a way to drain that area, so it kind of self-fixes itself. But if there was an issue like that, this is something that it would look like. So sometimes when you see pictures especially, it's hard to tell if it's because we're talking of a larger individual, someone's just a bit chunky, or is it because they have edema? Well, the best way to know that in terms of lymphedema is to look at the symmetry between two sides. You normally find lymphedema only on one side. So look what the other side looks like, and if the other side looks what you would expect it to look, and the opposite side looks like very swollen, that's probably lymphedema then. This is all lymph that has been building up on this leg. Same with this upper limb. And this would be because the lymphatic system did not drain this fluid that was building up on here. So that's just kind of the clinical relevance again. Now we should talk about what the lymph is made of. And if you look at this list, it's very similar to what we saw as what plasma was made of, isn't it? Because plasma becomes interstitial fluid, which then becomes lymph. It's the same stuff, more or less. So within water, we've got a lot of proteins and we've got white blood cells. And then we've got all this other stuff. We've got glucose, fats, salts, and all that. One thing that we never should find in lymph is red blood cells. We should not have red blood cells in our lymph. If we have, then there's something to be concerned about. So just kind of something to know. Where lymph is made, initially, lymph is produced at the bone marrow, and then we might have specializations in other parts. Lymph also gets done to a certain amount and especially filtered, maintained at the lymph nodes. So that's kind of what I wanted to say about lymph. Now, the last big thing that I want to talk with you guys is the lymphatic tissues and lymphoid cells. So really, we're going to be talking about T cells and B cells. These are something that you're going to become familiar with. And then we've got a bunch of cells that support. So I'm going to jump into the next presentation that I had here. And what we'll notice that we have general tissue in all parts of the body, general lymphatic tissue, but then we have specialized tissues, either the lymph nodes or lymphatic organs. And those are the two that we will need to have a look in a little bit more detail. So let's start with the lymph nodes. And someone once described these lymph nodes to me that it looks a little bit like beans that are organized usually close to each other, like almost as a string. And I think the expression that they used that it looked like a pearl necklace. I think that either this person has really weird pearl necklaces or they're just very poetic. I wouldn't say that it quite looks that way, but it does look like there's blocks that are organized in a row. So they are these glands that are a little enlarged and they enlarge even bigger if there's some sort of an infection in your body. Usually there's about hundreds of those in your body, and they make long strings. So we find lymph nodes in certain areas as packed. And they really, their function is to fight against anything that shouldn't be in your body. So they filter the lymph, and they also do the immune system surveillance. And that's why we talk about the immune system on this chapter. So those two are connected. So let's have a look of where in the body you might find lymph nodes. And again, this slide or this diagram that I'm showing is going to be available for you to download from the Canvas. So we find lymph nodes at the cervical area, that's our neck. We find also them at the axillary area, so in your armpit. So it's not just in your neck that your doctor might look for lymph nodes. Armpits are really big site of where we find a lot of lymph nodes. We also find them at the supratrochlear area, so above the cubital fossa, above the trochlear notch. At the inguinal area, so at your groin area. Obviously, for obvious reasons, we don't really go and check these normally, but if we have no other option, that might be one side where to find lymph nodes. Also at the abdominal area and at the thoracic area. Usually these are easily accessible, so we can feel them and we can find out if the lymph nodes are enlarged, if they're sensitive to touch. That's what we want to do in a clinical sense. And this is nothing that you need to know about. I was just learning about how does this reflect then in other animals. And of course, after this, I've been checking my cat's lymph nodes, and she's definitely not happy about that. But I'm all about challenging myself. So what should I say about the lymph nodes? They're small, bean-shaped. They're not much bigger than this at the largest, so about 1 inch in size. What we find about them is that they have an external capsule that they're closed inside, and then this capsule extends inwards to the lymph node. And that generates these kind of compartments inside the lymph node. And there's going to be 2 regions, and we've seen these regions elsewhere in the body as well. So we have again cortex, and then we have medulla. And this is actually a histological sample. So someone cut a very thin slice of a lymph node and then stained them and made a microscopic slide out of it. And if you look, you can see very much of the same stuff that we've seen on this diagram. So only reason why I have this here is trying to convince you that I'm not making up this stuff to make your life miserable. I promise I'm not. So we can study more about what's in the cortex, what's in the medulla. That's more detailed information. But what I want you to know is if we look at a single lymph node, is that there are certain vessels that bring the lymph into the lymph node, and they're always on this concave side. And then there's certain vessels that take out the lymph from the lymph node, and they're always on this kind of inward side of the bead. So the vessels that bring the lymph to the lymph node are known as afferent vessels. How I think of these is that afferent is when you arrive somewhere. Then the lymph travels through the lymph node and then leaves the lymph node through efferent vessels. So efferent, I associated that with exit. So afferent because you arrive somewhere, efferent because you're exiting somewhere. Whatever rocks your boat. You can also think that A is before E in alphabet. So A has to be the one that you come first, and E is where you exit. Whatever helps you to remember those. But afferent vessels bring something in, efferent vessels bring those out of that structure. So lymph flows through the lymph node in a very organized manner. That's how the lymph nodes are able to filter the lymph and perform the immune surveillance. So I would note those two terms. That would be very, very useful, so that for each lymph node, we have afferent and efferent vessels. Afferent ones are the ones that bring the lymph in. Efferent ones are the ones that take it out from that lymph node. So, did I go too fast? So, what else can I say? I think I was mainly going to go back to talking about checking the lymph nodes if they're swollen. That's one of the easiest things to check, one of the simple initial ways of looking. Do we have inflammation somewhere in the body? These lymph nodes swell because if there's an inflammation, the amount of white blood cells will increase, and these white blood cells are held within the lymph nodes. So now they physically have to grow to facilitate all of those white blood cells. Theories, as also the doctor wants to feel if they're swollen for you to say that, yeah, they're sore to a touch or sore in general. If you don't feel any sensation on those, that can be a sign of a cancer, but it's not that black and white. So don't go feeling yourself and being like, oh, I can't feel anything, I must have that. It's not quite that easy, but that would be one of the diagnostic, one of the many things that we're looking. But it should hurt if you push it. So don't now think that you have anything going on that you wouldn't have. It's just one of the many criteria that we're going to be looking at. I'm just looking at my cat who stole my pen. So next thing we need to talk, and the last thing we need to talk in terms of the lymphatic system, is the lymphoid organs. We have certain organs that play an important role in the lymphatic system. First one that we're going to have a look at is spleen. Spleen is only located on the left side of your body, just underneath the stomach, on the kind of far lateral side, far off from the midline. About a fist-sized organ, and it has many, many functions. First thing to note when we're starting to talk about its functions is that it receives a lot of blood supply. So spleen receives a lot of blood. So it plays a role in filtering the blood, removing old blood cells, removing old platelets from the blood, removing stuff that shouldn't be in the blood. And that's also, because we're talking about lymphatic system and immune system, that's a site where a lot of the immune cells are housed, and they go through the blood that is there something that shouldn't be there. That's also a site where white blood cells can then increase in numbers if there's something that we need to react to. Some of the other functions, we also store any leftover parts of the red blood cells. So, for example, iron that we can use later on. We store other parts of the blood there. In a newborn or fetus, that's where red blood cells are also produced. And again, that can be then further divided into compartments, and we could analyze that in a greater detail. We're not going to do that on this review level of structures. But no spleen, that's the biggest lymphatic organ that we have in our body. That's the biggest one to know. Well, let's move on in the interest of time and have a look of what happens if we need to remove a spleen. That can sometimes happen because we have such a thin capsule around the spleen that any direct flow or any sort of other physical impact can cause it to rupture. And in the past, we removed spleens quite easily, and liver and bone marrow can take over much of its functions. However, if you have a younger patient, you normally don't remove their spleen, even if it's damaged, because even just a little bit of spleen can regenerate and regrow that organ then. Can you take it easy? That cat is going crazy. So that's what I wanted to say about spleen. The next one that I wanted to talk about were our tonsils. And remember that we've got many different tonsils at different parts, all around the pharynx. So we have, depending on what part around the pharynx, we name them as palatine tonsils, lingual tonsils, pharyngeal tonsils, and tubal tonsils. So it kind of depends where we're looking. But really the function of the tonsils is to do the lymphatic system functions, immune system functions. We're filtering, is there pathogens, is there invaders that are trying to get into our body. Usually in this case, because since we're around the oral and nasal cavity, if food or air would contain something that shouldn't get past. So that's our tonsils. I don't know how many of you have had tonsillitis. That's an inflammation of the tonsils. Some of us might have even had tonsillectomy, where tonsils get removed. That's where you have consistent, frequent tonsillitis, inflammation of the tonsils. At some point, it might be decided that let's remove just tonsils. This was very common, especially in the 90s, 80s. Now we're less likely to do that because we're finding out that tonsils are an important part of the lymphatic and immune system. So let's not remove that because it might have an effect on your immunity. This is the beauty of the things in my mind, that we don't really know, and we're learning constantly more. But this would be an example, if anyone is easily grossed out and look at it, what tonsillitis looks like. So I lived most of my life like that. I had my tonsils taken out only a couple of years ago, and I tell you, as an adult, it's much more painful and much slower, the recovery. So that's all I was going to say about the tonsils. We also have something known as Peyer's patches. These are in the small intestines, at the end parts of the small intestines, little dots, a little bit like tonsils. And their function is really to just destroy any bacteria that might be there and serve also immunological memory, which we will talk in the next section. So that's all you need to know about Peyer's patches. Appendix is the one that I do want to highlight here. When we finish with the small intestines and we move to the large intestines, so mainly our colon here, the first part of the large intestines, our cecum, has a little bit of an outgrowth from it. This is known as our appendix. So appendix is a part of the lymphatic system. Its function is really to destroy any bacteria that might be there. And again, those memory cells for the immune system are housed there. Can you take it easy? Most people know someone who has had appendicitis, and some might have had their appendix removed. Well, why would we have something in our body that gets easily inflamed like this if it really, we don't know what purpose it serves? Well, this is because, and if you go shopping on Amazon, you can find all sorts of toys. That's your appendix. What we end up finding is, I'm going to go back just that everyone can see whatever there was on those notes. Appendix is most likely an evolutionary remain that's there. It doesn't serve a purpose anymore. Back in the day, when we ate more plant-based food, that's where we stored the bacteria that were able to digest that plant-based food. But now that our diet is much more mixed and much more processed food that we consume, we don't anymore need those bacteria in our digestive system. So also appendix keeps shrinking in an evolutionary sense. And eventually I expect that appendix will disappear from humans, but we're not there yet. So as long as we still have appendix, we might have to deal with inflammations of the appendix. That was the toy that I was showing. I've got all sorts of cartoons that I've included there. We don't really know what appendix does. So that's just a mystery, but most likely it's just there as a evidence of evolution. Another good evidence of evolution is our tailbone. We don't have a tail, yet we have a tailbone. Well, I guess that we at one stage, or our ancestors early humans might have had something like a K. I think this is the last one, if I remember correctly, of the lymphatic organs, our thymus. Our thymus is located at the inferior neck. I really think that we have discussed about this earlier on. That's where the T cells go to mature. So since the word T or letter T on those cell types, it's the structure that was largest at the childhood, large also during your puberty, but then shrinks and gradually gets replaced with connective tissue and adipose tissue. So that's pretty much all that I had to say about our immune system. I know that was a lot in a short amount of time. Remember that you have very good videos that are going to be made available as well, and so on. Do you have any questions about the lymphatic system at this point? Ew, there's a spider there. Well, I also do have a snake on my floor. I just put a bucket over it because I didn't know what to do about it. So if I do a runner all of a sudden, that's why I do it. Life here in the sticks is so...
Like you have a snake in your house?
Yeah, I had a snake in the morning on the floor and I really didn't know what to do about it. So I did put a bucket over it, and ever since then, it's been there. So maybe I know what to do about that. I have a little bit of an issue because I don't really like snakes, but I also have taken the oath to preserve all life, so I don't really know what to do about it.
Oh, I hear that. Everything looks good.
Life becomes difficult when that happens. So do we have any questions about the lymphatic system? Really keep it simple. Don't think you need to be experts, because this is just review, and these chapters, we could spend a whole degree learning about these and still not know enough. So what I want to do next is just talk really quickly about the immune system, and I'm going to do it in 15 minutes. So we can wrap up in time. Really, the immune system is the defense system against pathogens. So immune system is all about being more of a functional physiological system than an anatomical system. So we remember that's why we talked about the lymphatic system first. What we want to know is that there's many different kinds of pathogens. So pathogen is a term that refers to something that's an invader into our body, that shouldn't be there normally, that's trying to get into our body. And there's many different kinds of pathogens that try to get in our body, sometimes succeed, sometimes don't. Parasites, protozoa, such as malaria, fungi. I think athlete's foot is a good example of that. And then, of course, we have viruses. And COVID-19 would be a very good example of what viruses do. They spread around the world very fast, whereas some of these more simpler or more cellular-based pathogens, such as parasites or protozoas, plasmids, they are more linked with being able to manage with good hygiene practices. But I'm just wanting to show that there's a variety of different kinds of things that try to threaten us and our well-being. There's two ways of dividing the immune system. Sometimes we talk about innate immunity. So that's something that's just a very general response to any pathogen that tries to break into your body, tries to proliferate there. So that's kind of a one fit for all response to these pathogens. And that's what we're going to be focusing on first. And then the second kind of immunity that we might have is the adaptive immunity. That's very specific. That's against of certain specific type of pathogen. And that's what we often think of when we think of immunity, that, oh, I've been exposed to this, now I'm immune to that. And we're, for example, assuming that is COVID-19 infection going to give us immunity against it. We don't know for sure. If it does, then great, because then we could come up with a vaccine where we give a small amount of that virus, or we give a non-living part of that virus, or only section of that virus to an individual, and your immune system generates an attack against it and a plan how to attack in the future, and now you have immunological memory against that pathogen. But we don't know for sure with COVID-19 yet. That's why it's so shaky, and we need to be a little bit more careful because we're not quite certain just quite yet. But let's have a look of the innate immunity first. However, I do want to show that these two, even though it's a division into two, they have some overlap, and often one helps another, so it's not quite as clear division into two. So we're going to be focusing on the innate immunity first, and then just mention a very, very few words about adaptive immunity. So innate immunity was this one fit for all pathogens, and we have various different levels of defenses against these pathogens. And what would be the easiest way for you to protect yourself against an invader? Well, that would be to have some sort of a physical barrier. You can think of an old medieval castle. What's the best way for us to protect ourselves against an invader? Let's build walls around. So that's what your body has done by building skin around you. Skin is a really good barrier to keep outside anything that shouldn't get into us and keep inside what needs to stay inside. So that's one example of first line of defenses against pathogens. Remember though that if you cut your skin, there's a break in the skin. That's why it's so dangerous. Not so much that you're going to bleed to death if you have platelets, unlike me, but because that's an open route, open entry to your body for any pathogens. So that's why skin cuts are so concerning to us, and we try to clean them, we try to protect them, that nothing gets in there, and so on until they're healed. But remember that we can't have skin in all parts of our body. Certain parts, such as our nasal cavity, our digestive system, our urinary tract, there's no skin there. There's mucous membrane there. So these are not quite as good as skin, but these are physical barriers where we're still trying to keep the pathogens outside. Well, that's our first line of defense. The second line of defense is using chemicals to keep pathogens out. And one very good chemical that actually protects us very well against pathogens is the sweat on the top of the skin. So a lot of pathogens are killed, eliminated through that. Also notice our skin has an oil layer on top of it. That oil is again antibacterial, antimicrobial, so that protects us as well. Other example that I listed there was that think of sometimes we eat stuff that we're not supposed to, and I'm not talking like eating fun stuff, I'm eating something that might be poisonous or might be living thing that we shouldn't get into our food, into our body, such as a parasite in the meat or so on. Well, one way to deal with these things, if we get them through the physical barriers, and yes, in this case, if we swallow something, it's going to get through the physical barrier, would be to have highly acidic solution where we dump that thing. And stomach acids are a good example of that. So we kill anything that gets that far by a chemical defense, second line of defense of the innate immunity by stomach acids. Tears are another good one. What we end up finding that it's really easy for most chemicals and most microbes to get through to your body through your eyes. So most of the poisonings are actually because of chemicals getting to our body through the eyes. So tears have been our body's adaptation to that. So let's generate tears that are an excellent chemical protection against pathogens. And final example that I had, if you think for example, after intercourse, especially males, but also females get a need to urinate. That's washing away anything from the reproductive tract that shouldn't be there. In case of the males, females, they are separated. But on females, you can think of then again the short length of the urinary tract. That's why females get more UTIs. So I had some pictures about that. Really, those are the first and second line of defenses. We can also have cell responses. And these cell responses can include, for example, phagocytes, which are special cells that are adapted to eat pathogens that come into our body. So basically what they do, they take in the pathogen into the phagocyte. And again, I'm trying to find a pointer. There inside the phagocyte, this vesicle where the pathogen is fuses with another vesicle where we might have enzymes or some sort of other materials that break it apart, and any leftover parts that are now waste get dumped out of the phagocyte. That's how phagocytes protect us. As a cellular response. We also have something known as NK cells. These are natural killer cells. What we see here is on yellow, a natural killer cell. This purple one is actually an embryo. So this natural killer cell is attacking an embryo. So how natural killer cells work, you can consider them as sheriffs or police of the immune system. They patrol around your body, and when they find something that shouldn't be there, they act on it. So how they act on these is through apoptosis, and this should be a term that you should know from 181 or 156 biology classes. Apoptosis is when you trigger a cell to commit a programmed cell death. So these natural killer cells trigger these cells, invading cells, to commit a suicide. We can also have inflammation, which is a cellular respiration. Inflammations are responses to different kinds of injuries on your body. Inflammations are usually actually serving a beneficial purpose. When a site of your body is inflamed, that inflammation stops that pathogen from spreading to other parts of the body. It also removes these pathogens. It alerts rest of the immune system that, hey, there's a pathogen. And it also helps to generate conditions that are optimal for the repair of that site. So often, for example, by increasing the temperature of that site. So let's have a look of the signs and symptoms of an inflammation. This would make a great example. What are the signs and symptoms of inflammation? So there we have a couple of body parts that have been inflamed. I think that's a wrist and then the toes of a feet. So inflammation is always a response to some kind of injury, and it depends of the classification whether we say that there's 4 or 5 signs and symptoms. Well, the first one that we notice, that inflamed site is usually red in color. That's because there's now a lot of blood coming to that area. So we're seeing a lot more color there as well. Inflamed sites also are warmer. There's a little bit of heat on these areas. That's because this blood from the core of the body is now flowing to these sites. And in addition, this heat, this added temperature helped some of the healing processes on that side. We end up finding swelling on these areas. I think on these toes, it's pretty obvious. That's because now there's a lot of cells, a lot of blood and a lot of white cells coming to this side. So this area physically has more stuff, so it swells. Another thing that happens, these areas are usually painful. So the logic behind that is that when they're painful, we don't end up poking and touching inflamed areas. We let them rest and heal. And same goes for the fifth, which is sometimes listed, sometimes not, impaired function of the area that's inflamed. Well, the idea is that let's not use that part that's inflamed. Let's let it rest. So all of these help us to heal, help us to get better. And can you generate an artificial inflammation? Yes, you can by doing something known as sauna. I'm not going to talk about pus. That's it's just a fun story that I was going to tell you what happened when I was teaching about pus. Let's then have a look at two last ones. We have antimicrobial proteins. These are not often our interferons. And then we have fever. Fever is a sign that our immune system has been activated, but it also serves in a positive way of our recovery. It inhibits the microbial growth at that area. It increases metabolism. Remember, metabolism was all chemical reactions in the body, in that side. And then in addition to that, it increases phagocytosis, so eating invaders in our body. So fever is beneficial. Well, again, can we generate an artificial fever? Yes, we can, by going to sauna. So my people were the ones who invented sauna, so we're very proud of that. And that's why I always bring it as an example. So that's all that I was going to say about our innate immunity. Then we have our adaptive immunity, and I don't expect you to know too much about that, so we're not really going to revise it on this review session. I just want to say that adaptive immunity is known in Europe as acquired immunity, which I think makes more sense. So it's something when you have seen a thing before, that you develop a response against that. And I'm just going to show you, I would want you to know what an antigen, thank you, we're just going to finish in the next few minutes, but I'll just check the video. I want you to know the difference between antigen and antibody. So you remember, antigen is something that shouldn't be in our body. It's a pathogen, it's an invader in the body. And antibody is what we use to recognize that. And then I wanted to show one more thing, and then we're going to wrap up. And that was our primary and secondary response to an encounter with an invader. So primary response is when we meet something for the first time. It takes several days for us to react to it. Usually the peak is around day 10 after exposure to a pathogen. And secondary response is when we've seen this pathogen before, and now it's within hours that we start to generate a reaction against it. And the peak reaction is within a couple of days, and it's much more stronger response to that. This is what we talk about when we talk about immunological memory. And let's have a look of a visualization of it. So here we see arrow shows when we are first exposed to a pathogen. We're going to generate our primary immune response. So within few days, and around day 10 is when we get our maximum response. So you'll see the amount of response here on the y-axis. Well, if we have already seen this pathogen before, we have generated a memory trace against it. Now when we get exposed to it for the second time, our secondary immune response is quick. Within hours, within a couple of days, you get the maximum response, which is much, much, much stronger than what we saw before. So this is how all the vaccines work, for example, that we get the primary exposure and primary response. But now that we have these memory cells in our body, if we ever face this pathogen again, we automatically go to the secondary immune response. So that's the goal with vaccines. And that really finishes off all that I was wanting to say about the immune system. So I know that it's a lot. I know that it's kind of hard to formulate a good, deep understanding of it, since it is such a big topic, and we would probably need to spend, if not just days, maybe even months, to have a good appreciation of what's happening there. I'm gonna jump back into the PowerPoint that we were using earlier on to wrap up this session. Let's jump here. And what we see, we have pretty much gone through all of the key things that I wanted us to do today, which was to go through the assignments and highlight that there's going to be this lab that's going to be a little different from what you've seen before, but it's actually kind of a nice one. So please give it a go. Make sure to download the slide. Thank you. And then remember that next week we're going to do the exam and lab work. That's all I have for today. If you have any questions, give me a shout out now, or you can ask after the class. But I don't really have anything else for today. Thank you. Thanks for joining me. The video will be there later on. Have a good rest of the night.